Hello, ladies and gentlemen, boys and girls, children of all ages. I was recently going over the story of Eratosthenes, and he's the Greek mathematician who's credited with measuring the circumference of the globe Earth by his story is he was looking down a well, and I believe it was Alexandria, and he knew the sun would shine straight to the bottom without touching the sides. And in Syenne, again, that wasn't the case, that even on the summer solstice, I believe. So here, how would I just go over some of his info here? Here's Eratosthenes. I believe he may have been an alien from the size of his bulbous head, but maybe not. It's a long time ago for aliens. He's best known for being the first person known to calculate the circumference of the Earth, which he did by using the extensive survey results he could access in his role at the Library of Alexandria. And his calculation was remarkably accurate. He was also the first to calculate Earth's axial tilt. Ooh, what do we got there? It will pop up. Axial tilt. In astronomy, axial tilt, also known as obliquity, is the angle between the object's rotational axis and its orbital axis, which is a line perpendicular to its orbital plane. Equivalently, it is the angle between the equatorial plane and the orbital plane. It differs from orbital blah, blah, blah. Okay, anyway. Axial tilt. That's not really relevant for the entire thing here. So, let me get to the point. I was going over Eratosthenes and his measurements, and it occurred to me that, if you could, let me just get to this there. Sorry. Yes, he was highly esteemed, and yada yada. Measurement. There we go. Okay, so I'm reviewing his measurement of the Earth's circumference. And if you look on the picture here, it clearly seems to show the sun rays coming in like this. Here is the planet. Here's one city. Here's another city. This city is pretty much in straight line with the rays, as we see. That would be where the light was going down the well. So this would be Syenne up here, I guess, then. And he put the thing in and measured the angle of the shadow from the stick, so he could compare the two and determine the circumference of the Earth. Well, as I was looking at this, it occurred to me, like, you could also, knowing the distance between these two, which is 536 miles, you could triangulate the distance to the sun, could you not? Just a thought. So I thought I would do that. I'd just get the numbers and see if I could, do something along that. I mean, maybe you can't do that. I didn't quite get that far but you can see the picture here. Clearly, it shows the angles, and the whole story hinges on that he got those angles, and then was able to do math and figure out the circumference of the Earth. Let's see here. What is this stupid character? No. Is it blocking up on my head? I'm going to close this. I don't want to ask you a question. I want you out of my way. Oh, Jesus. Why? This wasn't here last time I tried to do this. Oh, hey, you fucking piece of shit. Fuck you. Anyway. This is fucking Britannica. You suck ass. You useless, worthless crap. Yeah. Okay. We'll just forget Britannica. Fuck Britannica. They're the ones that think that they need to put a banner up under everybody's videos if they talk about chemtrails or flat Earth. If it was if it was so true, they wouldn't have to run things saying that it's not. If their story was correct. But anyway. Okay, achievements, yada yada. Where are we at here? here? Number theory? Okay, I didn't get that far. Let me get back to the point here. Point is this. Here's Eratosthenes. He supposedly did this right here. Here's the sun angle down the well. Here's the angle. He takes the degree and then calculates the circumference of the Earth. So I wanted to calculate the distance to the sun doing the same method, knowing the distance between the two cities. And so I Googled the angle of sunlight at summer solstice in Alexandria. And Google says roughly 7.2. And so I Googled the angle of the sunlight in Syenne, and it is also roughly 7.2. Now, if you're trying to that shouldn't be possible on a globe, to tell you the truth. Either Google's wrong or lying, or Eratosthenes never did that measurement. I mean, because the shape of a globe, you go around a globe. Where was I? There. Get back down there to our picture. You just move a little ways on the circumference, and the angle changes because of the circular shape, and not just because the sun is parallax to it. There shouldn't be much parallax because the sun's supposedly 93 million miles away, so there should be no parallax. So all of the difference between the angles would be as a result of the round shape of the supposed globe Earth. However, we go to here, the angle is 7.2, the angle is 7.2. So, my question is, what in the hell did Eratosthenes measure? How did he measure anything if it's the same angle of light at both cities? That suggests a flat plane. If this was flat and not a globe, then we'd expect this angle of light would be the same as here, and it would get roughly 7.2 and roughly 7.2. So if the angle of the light is the same in both Alexandria and Syenne, then what in the hell did Eratosthenes use to measure? How did he get differing angles if they're the same? That makes no sense at all. And I don't know, it seems like I haven't quite got that far yet, but I'd like to calculate the distance to the sun. Oh, hey, thanks, LinkedIn. So anyway, yeah, that's my question. What the hell did Eratosthenes measure? He didn't measure jack shit. The whole story's made up. He was the first one to come up with make a map that was shaped like the globe too. First global projection. He was the first one to assume a spherical map. There we go. Well, anyway. Okay, so that's my video. What did Eratosthenes measure? I think if Google is not incorrect about this, then I think Google is showing us right here that the Earth is a flat plane. Everything else denotes it to be. Alrighty then. Have a good day. Thanks for watching.